Ever wonder what a microchip, your computer's memory, and a robot's brain could possibly have in common? Well, today we're on the hunt for a single brilliant idea that secretly connects them all. Let's dive in. All right, to get started, we're going to look at three problems. And these aren't just any problems. They seem totally different from each other, and they're all really hard puzzles from the world of computer science.
Okay, first up, chip design. Just think about it. Inside every single processor, you've got millions, sometimes billions, of tiny components that all need to be connected. So the challenge? You have to find the absolute shortest path for every single wire on this super crowded grid, and you can't let any of them cross or you'll get a short circuit. It's an absolutely mind-boggling puzzle.
Next up, let's talk about memory management. You know how when you're running a bunch of programs, your computer is constantly creating and storing data? But what happens when that data isn't needed anymore? How does the system figure out what's junk and what's still important? How does it clean up the mess and reclaim that space without deleting something you actually need?
And for our third puzzle, let's think about robotics. Picture a self-driving car weaving through traffic or one of those robots zipping around a massive warehouse. It has a simple goal, right? Get from point A to point B. But it has to find the most efficient path, all while dodging walls, people, and who knows what else.
So there you have it, microscopic wires, abstract bits of memory, and a real-world robot. On the surface, they have absolutely nothing in common, right? Well, what if I told you there's a single, fundamental idea that cracks all three of these problems, the exact same concept? Okay, it's time to meet the hero of our story, the secret ingredient that solves this whole puzzle. The answer is an algorithm called Breadth First Search, or BFS for short. Now, don't let the name intimidate you. It's a really simple idea for exploring any kind of network. We're talking circuits on a chip, a robot's map, you name it. And the key is that it expands outward, one step at a time, kind of like ripples in a pond. So how does this actually work? Well, the best way to get it is to think about a really simple analogy. I want you to picture dropping a pebble into a totally calm pond. You see that first little ripple expand, right? Then a second one follows it, then a third, and on and on. BFS explores a problem in exactly that same way. It spreads out layer by layer, and because it does this, it's absolutely guaranteed to find the closest things first. That's the secret. Okay, so here's the method. It's super methodical. You start at one point, your source. Then you look at all of its immediate neighbors, everything that's just one step away. After you've done that, you move on to their neighbors, everything two steps away. And you just keep going, layer by layer. By doing it this way, you are absolutely positively guaranteed to find the shortest possible path. All right, let's bring this back to our chip routing problem. The algorithm kicks off at the source point, and it looks at all of its immediate neighbors on that grid. Every reachable square right next to it gets labeled with the number 1. That's it. That's our first ripple. And then, from all those squares we just labeled 1, the wave expands again. The algorithm finds all of their untouched neighbors and labels them 2. And this wave just keeps propagating across the grid. It flows around any obstacles in its path until, bam, it finally hits the target. So now that we've got this idea of a ripple effect down, let's go back and see how this one simple trick solves our 3 big mysteries. So for our microchip, the second that wave of numbers hits the target, the hard part is basically over. The algorithm just has to work backward. It starts at the target, looks for a neighbor labeled 1 number lower, and then a neighbor 1 number lower than that, and it just traces this perfect, guaranteed shortest path all the way back to where it started. Problem solved. Okay, what about garbage collection in memory? In this case, our source points are the core, active parts of whatever program is running. BFS starts right there, and it just follows all the connections, visiting every single piece of data that's still being used. So on the left, you see all the data, kind of a mess, but then on the right, after BFS does its thing, you can see that everything it could reach is now marked. Everything else, that's garbage, ready to be swept away. And get this, some systems take it even one step further. There's this clever approach called Cheney's algorithm. It uses BFS not just to find the good data, but to actively copy it all over to a brand new, squeaky clean area of memory. This is genius because it leaves all the junk behind in one big chunk and keeps your memory nice and tidy. And that brings us back to our robot. You can probably guess how this works now, right? It's the exact same logic as the microchip. The robot's world is just a map, a grid. BFS expands out from where it is, exploring the map in those ripples we talked about until it finds its destination. Then it just traces its steps back, and voila, the most efficient collision-free route. So this all brings us back to our hidden hero, and really the main idea I want you to take away from this, the incredible, almost unbelievable power of a simple, fundamental idea. I mean, listen to this quote from one of our sources. These are not trivial problems we're talking about. Researchers consider them key challenges. And yet, a method that we can literally picture as ripples in a pond gives us a perfect, optimal solution. It's kind of beautiful, right? At the end of the day, breadth-first search is just the perfect example of a bigger truth. Our most complex, advanced technology is often built on a bedrock of elegant and, surprisingly simple ideas. It's a great reminder that being clever isn't always about being complicated. And that's where I want to leave you, with a question. If a simple rule like explore in ripples is this powerful and this fundamental, it really makes you wonder, doesn't it? What other simple rules are out there, hiding in plain sight, secretly running the whole show?